This is the key to rational expressions, and this is the worksheet called Extra number 3. So make sure you're looking at the one that says Extra. So in the problems that you see, you want to add or subtract. You want to add or subtract rational expressions. And the direction says make sure you show all work to receive full credit or any credit. For each, indicate the LCD. So you know there's a blank for the LCD in each of those cases. So let's look at number 1. So number 1, we have um, 8 divided by r to the 5th z squared plus 3 divided by r to the 3rd z to the 7th. Now, the interesting thing about number 1 versus the others is that if you look at the denominators, at least in 2 and 3, if you look at 2 and 3 versus number 1, these are monomial factors, whereas these are binomial factors. So r minus 2, x plus 3, r plus 6, r minus 6. And then here we have monomial factors as well. So in number 1, when finding the LCD of um, of denominators, basically you look at every factor. So you notice that in this denominator there are 5 factors of r. In here there are 3 factors of r. So you're going to use the one with the most number of factors. So you're going to need 5 of them. So I'm going to have r to the 5th as part of my LCD. Then you notice that you have 2 factors of z, 7 factors of z, so I need 7 of them. So you need 7 factors of z. So that's your least common denominator. So now what you're going to do is you're going to rewrite these 2 fractions with this denominator. So that's what you're going to do. Now I'm going to go ahead and kind of rewrite this, but leave some room so that way when I do the discussion, you'll see what I'm doing. So I have 8 divided by r to the 5th z squared, and we'll leave a little space here, and then plus 3 divided by r cubed z to the 7th. Okay, now, so all I did was just rewrite this. Now I want to rewrite this. I want to write equivalent fractions. So I want to rewrite a fraction equivalent to this one and write a fraction equivalent to this one that has this denominator. So that's the goal. So I want the new denominator to be r to the 5th, z to the 7th for both of those cases. So we're going to write equivalent fractions, So notice that in this particular case, I have 5 factors of r and I have 5 factors of r here. So I don't need any more factors of r. So I want to go from here to here. So I want to get 5 factors of r, which I already have. Here, though, I need 7 factors of z, but I only have 2 of them. That's a 2. I only have 2 of them, so I got to multiply this by z to the 5th. Because remember, when you multiply like bases, you add exponents. 2 plus 5 is 7. But what I do to the denominator, I do to the numerator. And so that's how this numerator here becomes 8z to the 5th. So 8z to the 5th. Okay? Then you do the same thing here. So notice that I want 7 factors of z, which I already have. Okay? I want 5 factors of r, but I only have 3 of them, so I've got to multiply this by another 2 factors of r. R cubed times r squared is r to the 5th. But what I do to the denominator, I do to the numerator. So this becomes 3r squared. Now notice I wrote equivalent fractions. So this fraction here, this rational expression is equivalent to this one. This rational expression is equivalent to this one. Now I have 2 rational expressions with the same denominator. So this just becomes, I can write this as one rational expression with that denominator. And all I do is add the numerator. So 8z to the 5th plus 8z to the 5th plus 3r squared. And those are not like terms, so that's all you can do. You cannot do anything else. So that's your answer. This is the work. This is the answer. Okay? Number 2. Okay, so when we look at number 2, we have 6 divided by x minus 2 plus 5 divided by x plus 3. Okay, so notice that the first thing you want to do when finding the least common denominator is always make sure that your denominators are factored completely. So x minus 2 and x plus 3, there's nothing much else I can do with those. So now I can find the LCD. Your least common denominator must include every factor that's in your denominators. So notice I have a factor of x minus 2, so I have to use it. In the next one, I have a factor of x minus 3. It has to be part of the LCD. It has to be part of my denominator, my least common denominator. Okay? And so now I'm going to write, again, I'm going to do the same thing I did with the previous one. I'm going to rewrite this over, but I'm going to go ahead and leave some room here and do the same thing here and leave some room here. So now I'm going to write 2. Notice the equal sign. This is equal to this, is equal to this, and so on. Those are mathematically correct statements. So I'm going to write 2 fractions, 2 rational expressions with that denominator. X minus 2, x plus 3, plus x minus 2, x plus 3. Okay? So the question is, 6 divided by x minus 2 is equivalent to what rational expression with this denominator? See, I have x minus 2, but I want this. So you think about what's missing. What do I need to multiply this by to get what you see here? Well, you see the x minus 2s. You don't see this here. So you got to multiply by this. You're going to say x plus 3, x plus 3. What you do to the denominator, you do to the numerator. So now this numerator right here becomes what you see here. So that becomes 6 times x plus 3. Okay? Then you do the same thing here. So I have x plus 3. I don't see x minus 2 here. So I got to multiply this by x minus 2. What you do to the denominator, you do to the numerator. So I got to say 5 times x minus 2. Notice the parentheses. That's going to be important. Okay? Now, since the denominators are the same, and leave them in factored form, don't multiply this out, because the whole point in leaving in factored form is that what you have left in the numerator at some point, you may be able to reduce. Okay? And you're going to see that in another worksheet. So be careful. Leave it in factored form. Don't multiply this out. Leave the denominator in factored form. Now, you want to go ahead and distribute the 6 here and distribute a 5 here, because you need to combine like terms in the numerator. So remember, when you when you add or subtract rational expressions, you have to get the denominators to be the same, which they are. So now you can write this as one rational expression. And so now this becomes, let's go ahead and distribute now. So this becomes 6x plus 18. So 6x plus 18. Now this one's not that bad because that's a plus, that's an addition symbol. This is subtraction. You got to be careful here. But since it's the addition, we're fine. 5 times x, 5 times negative 2. Okay? So this becomes plus 5x minus 10. Combining like terms in the numerator, I get 6x plus 5x is 11x. 18 and a negative 10 is a positive 8. And leave the denominator in factored form. Leave it like this. Don't do anything else. Now, at some point, you want to simplify this if you can. So remember in previous lessons when you simplified rational expressions, you want to factor numerator and denominator. See, the denominator is already factored. The numerator, you cannot do anything else to it. So you're done. That's the answer. Okay, let's look at number 3. Number 3, we have, let's see, number 3. Okay, number 3, we have 9 divided by r plus 6 minus 7 divided by r minus 6. All right, and so remember, your least common denominator must include every factor that you have. But to determine every factor, you got to make sure that all your denominators are factored. So in this worksheet, you don't have to worry about that, but in another worksheet you do. So you got to make sure that your denominators are factored. So there's not much else I can do with factoring r plus 6 or r minus 6. So therefore I can determine the LCD right away. The LCD must include every factor you see. So an r plus 6 and r minus 6. R plus 6, r minus 6. And now you're going to write 2. I'm going to rewrite this over, though, before I go any further. So I'm going to leave some space. Remember, that's subtraction. You've got to be careful with subtraction. Okay, so now I'm going to write two equivalent rational expressions with this denominator. R plus 6, r minus 6. R plus 6, r minus 6. Okay? And so now so notice I want to I'm asking myself, 9 divided by r plus 6 is equivalent to what rational expression with these two factors? So you see I have an r plus 6. See, I already have this. I'm missing this. So I got to multiply this by r minus 6. What I do to the denominator, I have to do to the numerator. So I'm going to rewrite in this numerator, I'm going to rewrite what I see, 9 times r minus 6. Okay? And notice that it kind of makes sense because if you divide out these r minus 6's, you're left with 9 divided by r plus 6, which is what this is. Over here, notice I have an r minus 6, so I'm missing this. Okay? This is what you don't see here. This is right, this part, this factor is what's missing. So I'm going to multiply this by r plus 6. What I do to the denominator, I do to the numerator. So this becomes 7 times r plus 6. Okay? Now, you got to be careful with subtraction. What I would do with subtraction is this. So let me go ahead and rewrite the first rational expression over, just like this. And what I would do is I would change this to an addition problem. So remember, you can always change subtraction to addition by adding the opposite. So this becomes plus a negative 7 times r plus 6 divided by r plus 6, r minus 6. And now you distribute. Now you distribute. So now I can write this as one rational expression, r plus 6, r minus 6. Again, leave it in factored form. Don't multiply this out, because what you end up with in the numerator, you may be able to reduce. Okay, so that's why you want to leave it in factored form, because that's going to help you to reduce if you are able to reduce. So 9 times r, 9 times a negative 6, I get 9r minus 54. Over here, a negative 7 times r is a negative 7r. A negative 7 times a positive 6 is a negative 42. And so now I have 9r minus 7r is 2r. A negative 46 and a negative 42 is a negative 96 divided by r plus 6, r minus 6. Now at this point, what you would need to do is see if you could see if you can reduce. So you at this point you would want to factor out the numerator, which you can factor out at 2, but it's not going to help you at all. Factoring out at 2 in the numerator will not help you to reduce. Okay, so if you leave your answer like this, that's fine. Or you could have said 2 times r minus 48 divided by r plus 6 times r minus 6. Either one of those is fine. Okay? All right, let's do number 4. Number 4, you have 2x minus 1 divided by 6 plus 3x plus 2 divided by 4. And so the LCD here is going to be 12. That's your least common denominator, 12. And so now you're going to write two equivalent fractions with 12 as the denominator. So I'm going to go ahead and leave some room here. 2x minus 1 divided by 6, leave some room, plus 3x plus 2 divided by 4. And I want to rewrite these two rational expressions with the denominator 12. So that's the idea. So this rational expression is equivalent to what rational expression with 12 as the denominator? So notice I have a 6. So if I multiply this 6 by 2, I get this 12. So you're going to say times 2, just like this. Now be careful, this whole thing has to be multiplied by 2, so that's why you saw me put a parentheses there. Over here, times 3, okay, because 4 times 3 is 12, so I got to multiply this by 12. And so now what you have is this. I'm going to just go ahead and write it. So now the numerator, you'll see it's 2 times 2x minus 1. Okay, that's the numerator. Kind of makes sense because if I reduce the 2/12, if you reduce the 2/12, don't you get 2x minus 1 divided by 6, which is what this is? Okay, so those are equivalent. And then do the same thing here. So 3 times 3x plus 2. Now let's go ahead and distribute the numerators. So I get 2 times 2x is 4x minus 2, because 2 times negative 1 is negative 2 divided by 12, plus, and then here you're going to get 9x plus 6 divided by 12. Now I'm going to write this as one rational expression. 4x plus 9x is 13x, right? And then a negative 2 and a positive 6 is a positive 4. And you cannot reduce any further. The 13x plus 4, the GCF is 1, so that's it. There's your answer. All right, so that was the key. That was the key to to uh, rational expressions extra number 3.